Well, I could give it a hug. It's just it wouldn't feel it.
No, stop it. Stop going near black holes.
Chelsea hugged a black hole, so it's just me this episode. Hi, I'm Leah Crane.
Well, actually, I thought better of it. I'm Chelsea White. Welcome to Dead Planet Society from New Scientist.
Today we're talking about black holes, but not the big behemoths you might be thinking of. We're going teeny tiny.
Yep, this episode is all about primordial black holes, which I'll warn you now, Leah doesn't exactly believe in.
I mean, I hope they exist, but I don't think they do, and a lot of scientists do agree with me. These are pretty controversial.
Okay, but why? Why are they so controversial? If they exist, they could solve some pretty big problems in cosmology, couldn't they? And they've been proposed as potential candidates for dark matter, the mysterious stuff that makes up a ton of the universe.
Well, they're controversial because there's no evidence that they actually exist.
Okay.
And they're so small that it would be nearly impossible to find that evidence. Like I said, if they existed, that would be great for cosmology and just because they're cool.
Yeah, and they would also solve a lot of problems that you and I create. We often hear from astronomers that if we want to, say, make something more massive or tug a planet somewhere, we could just employ a primordial black hole.
They may be tiny, but there's a lot of mass crushed in there, so they're really useful for our nefarious purposes.
And when we say tiny, we mean truly itty-bitty. We're talking smaller than an atom.
Black holes shrink through a process called Hawking radiation, and those really tiny ones would have been born right after the Big Bang and disappeared by now. But this is Dead Planet Society, so we don't have to worry about that.
So we got to talking, and we were wondering what would happen if we could control these tiny black holes. What would happen if we put one inside a planet, or a star?
Or a person.
Well, as you heard, we were warned by our guest today, Allison Kirkpatrick from the University of Kansas, not to get that close to them.
She immediately and very reasonably crushed our dreams. But she also helped us figure out what would happen if we put a tiny black hole inside the sun, inside Earth, or, inadvisably, inside a human being. Every time we need to add some mass to something to change orbits, someone tells us to just put a primordial black hole in it.
Sure.
Because, you know, they're nature's
small problem solvers.
Exactly. Because they're could be so small and very massive despite that. So I guess the first question is, do you think primordial black holes exist?
Sure. Why not?
Okay, tell us more about that.
I mean, there's no proof that they do, and there's no proof that they don't, so why not? Right, so the idea behind primordial black holes is that they're created very, very early in the universe, like within the first couple seconds of the universe, when expansion was starting, but some pieces of the universe would have been overdense enough that they would have collapsed into black holes. But these would have been really small. And so the problem with primordial black holes is that, Stephen Hawking did a lot of work on these. They should have all radiated away by now. But if you can grow enough and you can accrete enough mass, maybe you wouldn't have radiated away and you'd still be around. So there are people today who are looking for primordial black holes. Just to throw some actual science at you, one of the thoughts behind the LIGO results. So LIGO detected gravitational waves of black holes that merged together. And it was really surprising, the very first results, and actually every result since then, that the black holes that they're detecting are too big. They're bigger than you can produce with stellar models. They're like 30 solar masses, 50 solar masses, sometimes even bigger than that. Having one of those, okay, so maybe you just happen to have a really big star. Having the amount that they're finding, we just don't form stars that big in that kind of abundance. And so one possible idea, this is not accepted, but one possible idea would be that those are actually primordial black holes.
Which meant they had like enough time to get that big?
They have accreted material, or they were formed at that size and just they wouldn't have had time to radiate away. The limit by which you could still exist today is if you have to be about about 1/trillionth of the sun. You had to have been formed about 1/trillionth of the size of the sun, and you would still be around.
How big is that?
You mean physical size?
Yeah, like could
look
I
at my
give it a hug, or is it like
no,
the
you
size
could
of
not.
a...
So I calculated this, and if you are a trillion kilograms, which is the limit by which you wouldn't have radiated away, and now I'm actually, and I said that wrong. You're not a trillionth of the sun. You're 1/10 to the 18th of the mass of the sun.
You're a billion billionths.
A billion billion.
A billion billionth of the sun.
1 in a billion
Yes.
billion.
Okay, so if you are that size, then your event horizon is the size of a proton.
Oh, well, I could give it a hug. It's just it wouldn't feel it.
No, stop it. Stop going near black holes. Okay, so to put this mass in context, I did a little research for your readers to try to see if I could come up with something. It'd be about the mass of a comet. Okay, well, we don't see comets every day. So it is in between the mass of the iceberg that the Titanic hit and Mount Everest. So yeah,
But
so
the
something
size
like
of a
that.
proton.
Yeah, so let's say Mount Everest, the size of a proton.
Wow. Okay.
Okay.
Huggable.
And it seems like given that given that in theory, let's just say we have it, we could get pretty much any mass we wanted by just slamming them together.
Yes,
Slamming
exactly.
what together? Oh,
These
two
your black
primordial
holes.
black holes.
Mm-hmm.
Yeah.
Mm-hmm.
So we could make it big enough that you could hug it. You die.
Yeah. Well, you're gonna die anyway. But
Truer words have never been spoken.
So yes, the idea is that these things, like particularly the black holes that LIGO has been founding, they probably formed from dead stars. They're probably not primordial black holes, but either way, they would have grown by merging together.
Going back to where we all started with this, if we put a black hole inside a planet, like
Even just a proton-sized one.
yeah, little tiny one, and we put it in the core of Earth, like maybe there's a little spot for it, what would happen? Would we notice if we took out the same amount of mass and put in,
You don't even need to take out the same amount of mass because this is already 10 to the 12 kilograms is already much smaller than the Earth. That is a trillionth of the size of the Earth. So if you added a 1/trillionth of the Earth's mass to it, nobody's going to care. You need it to be a little bit more massive to actually do anything. At that small mass, it's not going to do anything. If there was a black hole inside of the sun, because this is one idea of like, where have all the primordial black holes gone? Well, what if they're just inside of things? What if they're just inside stars? And so what would happen is you have a little primordial black hole inside your star, gets a little accretion disk around it.
Tiny little accretion
I
disk.
know, it's a little baby accretion disk. And it can add maybe like 0.1% to the sun's luminosity.
Oh.
But if it is 1/millionth the size of the sun, okay, so that would be Earth, right? If you take a black hole that has the same mass as Earth and you put it inside the sun from its beginning, at this point in time today, we still wouldn't know. It'd only be adding about 0.1% of the luminosity. But right after today, things are about to get really bad because it's finally accreted enough mass to matter. And then actually the solar luminosity comes primarily from the accretion disk around the black hole. And the radiation becomes enough that it turns the sun into a red giant. And so it shortens the sun's lifetime considerably. And so if this is the case, then we'd only have about 100 million years left.
Okay, well, it's not like the day after tomorrow.
It's not. Sorry, things actually take real time in the universe.
Yeah, I
They
don't
take
like
a long
that.
time.
Longtime listeners will know that I have beef with time in general. So,
Yeah.
It seems like we still wouldn't be able to see it now.
Right. Would you rather be on a planet where your sun is going to live 100 million years or a planet where your sun is going to live 5 billion more years?
I don't care.
Frankly, those are the same to me.
Yeah, fair enough. But no, you still wouldn't see it. You still, to answer your question, no. It would still look like a star. And we would just look like a red giant. And so then the question becomes, how do you detect this? it could create some perturbations on the surface. You could look
That's
for,
all we got?
Yeah. Yeah.
Marginally
So
different
sorry,
type of
if we
radiation.
throw a black hole in the center, and this is really cool. There could be black holes hitting us all the time. So these primordial black holes, these primordial black
Pretty
holes.
sure there aren't.
But no, I'm gonna get it. And let me unpack this for you.
Please.
Yes. So primordial black holes, again, we're talking about size of a proton, possible dark matter candidate. They will have a high velocity at this point in time. If they are dark matter, then we should have like millions and millions and millions and millions of them around us. And if they're moving at a high velocity, then what'll happen is they'll just like fly right through the Earth. And they would create, like, you'd get like an earthquake, you'd get a crater. It'd be like being hit with something that you can't see, but it wouldn't stop. It wouldn't slow down. They're moving too fast. And so they would just like move through the Earth. So there was this great study done a few years ago trying to constrain the amount of dark matter that is actually like around us rather than, in our halo, by looking for unexplained deaths. And they, because
I was going to ask if it would like cause a stroke sometimes.
No, it would be like being hit with a bullet. It would just
But like a
zoom
ghost
through you.
bullet.
Yeah, exactly. A ghost bullet. So if you got hit with one, you would die.
Sure.
It would like rip some stuff up in there. But your body's not going to like fall into a black hole, so you would just die. And so this study looked at unexplained deaths in Canada. Basically, they combed the Canadian like archives of deaths and looked for unexplained deaths. This study, while a great idea, does not actually work because death certificates are really inaccurate.
Okay,
So
fair enough.
that's the problem. But yes, if you're walking along with someone one day, if someone just keels over next to you and it's not a stroke and it's not a heart attack, it could be a primordial black hole.
Put it on the death certificate.
Could we do it by looking for like unexplained craters? Since you said they'd go through the Earth. They'd be really small though, right?
Well, you're getting hit with Mount Everest in the size of a proton, although it's probably bigger than that by now, right? So it's probably a little bit bigger. Ideally, you don't want to be hit with an Earth mass one.
Yeah, ideally, no.
Yeah. So we don't want that. So I imagine that the crater that it would create would be pretty big.
Now we have a special offer for Dead Planet Society listeners. You can get a 10-week digital subscription for $10 or £10, which includes unlimited access to our website and app. To learn more, go to newscientist.com/DPS offer.
And if you enjoy our podcast, you might also enjoy my free monthly space newsletter at New Scientist, Launchpad. Check it out at newscientist.com/launchpad. And if you love eclipses, New Scientist Discovery Tours now has 2 new eclipse tours live on our website. One going to Greenland in 2026 and another sailing the Nile in 2027. Go to newscientist.com/tours to find out more.
I'm just thinking now. Oh, I have so many thoughts. I'm just thinking now, instead of being hit by one, like cascading at me from all over the place, thank you for this new fear, could we place a black hole inside a person?
Right, like artificial insemination?
No, I just want to eat it. I don't, no. No, thank you. What I want is to eat a primordial black hole, and it can have zero velocity. I'm going to pick it up.
So let me explain to you what would happen. So no, you can't. I'm sorry. The reason is
my dreams.
I know. So let's put the primordial black hole in your stomach. And so we're going to stay with this Mount Everest mass one. And if you
you can't move, you're done.
Yeah. If you put it in your stomach, the force on your head will be 10 times greater from the black hole than the force on your head from the Earth. And so you'll just collapse.
Like straight down through your gut.
Yeah,
like
the gravitational
implode.
force on your head you'll just collapse, and it'll take less than a second.
Oh,
So you're just gonna accrete into that black hole.
But like you haven't crossed any horizon of any sort, right? Like it crossed my horizon.
you're not gonna. You will eventually cross the event horizon, but like the gravity is what's pulling you down. And so if you increase your gravity a lot, it's going to overcome the strength of like your muscles.
Fair enough.
Also, I think it would be really uncomfortable to have something the mass of Mount Everest in your tummy.
Yeah, even if I was able to even if I was super powered and didn't collapse,
It wouldn't
I would
feel
still
nice.
feel bad.
No. So maybe we'd have to do the math on this. Maybe your bones wouldn't actually collapse. Maybe your bones have a tensile strength that's enough to not collapse. But like your eyes would. And,
Yeah, but if
like,
I can
you're
turn
just,
myself
like,
into a skelly,
yeah, I think you'd turn yourself into a skeleton.
Can I turn myself into a skeleton by eating a black hole? Because I'm not gonna lie, sounds very rad.
It does.
I am into it.
But I will say that you can have a whole plate of primordial black holes at your dinner party as long as you stay about 10 feet away from them.
Okay.
Okay.
The worst appetizer.
Yeah. As long as you're about 10 feet away from your primordial black holes, then their pull on you is going to be less than the Earth's pull on you. So you're not going to fall towards them.
Could we use primordial black holes in any other interesting ways? Now I'm thinking about their power, their pull power.
No, but I just told you their pull power is not great unless you're like right by it.
Yeah, but I don't want it to be super great. What I'm wondering is, I was just thinking about how the moon is escaping us slowly, very, very slowly. Could we like stop it? Could we like put a little line of primordial black holes and just like tug it back ever so slightly?
We'd have to do the math, but if you put a primordial black hole inside the orbit of the Earth and the moon, but it needs to be really, really close, like right on the surface of the moon, then you'll get a little bit of an effect.
I had another idea because it seems like the problem with putting a primordial black hole in the middle of stuff is that even if it's very, very slow, eventually it is going to get that cute, adorable accretion disk.
No, it's not. Okay, so I am going to tell you you're wrong. You're wrong about because okay, this is another thing that I looked up just to make sure that this was correct. The stuff right next to the black hole, like I said, 10 feet from the black hole, it's going to have the same pull as the Earth on you right now. So the stuff around the black hole that's very, very close is always going to be pulled in. But what's our core made of? Our core is solid iron. So then you have to look at the tensile strength of iron. And at what point do you start to pull iron apart? You need a lot of force to pull iron apart. And so even if you grow your black hole, like let's say you accrete everything within, a few feet radius into your black hole, it's not that much material. So your black hole is not really increasing in mass. And now everything outside of that is attracted to all the other iron.
Ah, so we're just super not going to notice.
You're
So,
just
like,
super not going to notice.
If it were in the center of Earth, it would sort of like hollow out a little space for itself, a little cave.
Yeah.
And
Yeah, it'll
then
be a little cave.
everything else would just go on as usual.
And then it would float in the center of the cave because of gravity of a sphere.
Right. This is the idea of like why they are hiding in stars. Is that if you have like millions of these things and they're just floating around, then how do you get one in a star? When the star actually forms, your primordial black hole would fall to the center of the star because it's got most of the mass of your solar system. And then if it's small enough, it would just do that. It would just hollow out a little area. Then its forces would kind of be in balance and you just wouldn't know.
I love the idea of primordial black holes as like the hidden puppeteers behind all of the solar systems. Like, I do kind of think that's great.
It feels to me like a larval stage. Sorry. Feels to me like it's tricking us. Like we think everything's fine in there. It's just in its little cocoon. But eventually it's going to bust out.
So I have nightmares. One of my most recurring nightmares is that a black hole appears in our sky. And I know that like Earth is doomed.
Oh my God. What do you do in the nightmare?
Freak out. I panic.
You don't like get a large
I have an
potato
existential
gun?
crisis. No, I have an existential crisis. And then I wake up in a sweat.
At least if it was below us, just sort of slowly growing. If we put one in there that was big enough to rip apart the iron and accrete it, we wouldn't know until it reached the crust.
How would you feel if we were able to discover that there is a black hole of substantial size in the center of the Earth and it is going to consume the Earth, but we know that that timescale is 100 million years? Would it make you feel different about the Earth?
Yeah, actually, I think it would. I think it would make me appreciate Earth a lot. Like, I think, to know that it's fleeting. And also, I would probably end up having nightmares about the black hole eating us.
The opposite of most people's reactions, I think, which is it's gone anyway.
No, but like, that means that we are like the lucky ones who get to enjoy things like beer and lakes and, watching the stars.
It's true. That's true.
I feel like I would start digging. I want to know what's down there.
Go over to that cola. What was it? The super borehole, and fire up the machines, guys. We got to get that black hole.
Yeah.
Now,
I hear it. I immediately go get a shovel. There's a part of me that really deeply wants to put a black hole in the center of the Earth that's like Earth radius minus 10 kilometers.
Maybe like 15. Give us a little more space.
Yeah, okay, but let me tell you the problem with this. Right? Okay, so let's say that we could create a black hole using the Large Hadron Collider, and then you want that black hole to be in the center of the Earth. The problem is getting it there, because this is why there's such good dark matter candidates, because they only interact gravitationally. So you start shooting your black hole into the Earth, you have to slow it down somehow to get it to stop at the center. How do you slow down something that doesn't interact through friction?
Another one. Another black hole.
Okay, you're going to have two black holes come from opposite sides and hit each other.
Yeah.
Mm-hmm.
That actually might work. I like that. Okay.
I'm here with my black hole machine, just having duels.
If you do it wrong, they'll just bounce off each other with the same velocity going in the opposite directions, and they're just out of there. So you need them to have a little bit of material. You need them to have like little accretion disks. You need to get them to have a little material around them first so that they can get rid of some of that momentum into the material outside of them. And then I think you could merge them.
So they'd sort of like be like two ice skaters who come together and grab around each other's waists and start spinning.
Yes, that's what you want to do. Yes.
All right. Winter Olympics ice, black hole edition.
The problem is going to be the big holes they're going to bore in Earth on the way in.
Yeah, but we did this last season, and we decided that was great because you could skateboard through it. So I think we're going to...
I love it. Yeah, don't worry about the internal temperature.
No. It's fine.
We died in so many fascinating ways this episode. Woohoo!
And we ruined everything. Great job, everyone. And thanks for listening to Dead Planet Society. If you want to catch up on previous episodes, head over to newscientist.com/deadplanets. Look forward to new episodes every other Tuesday right here in the New Scientist feed.
We had a listener, Jay, write in to ask what would happen if we sped up Earth's rotation by a factor of 10.
Ooh.
Or 100.
Oh.
Or 1,000.
Yeah, let's do that one.
I'm pretty sure it would be a complete nightmare.
Yeah, but what a great question. I think it might keep me up at night. Just imagine, like, how insane the weather would be.
Every day would be like 90 seconds long. I love it. And if anyone else out there has a cosmic object you want us to figure out how to destroy, let us know and it could be featured in a later episode of the podcast. Our email is deadplanets@newscientist.com.
Bye.
Bye.
I just wanted to really advise you not to eat a black hole. I think that's going to be bad for you.
Unfortunately, I'm not currently accepting advice.
Oh, okay.